What if I told you that the most baffling object in the entire universe is currently passing through our own backyard? We need to talk about 3I Atlas. If you think you know what a comet looks like, I need you to forget everything you learned in school. Because what astronomers are seeing right now with 3I Atlas is rewriting the rulebook. We are watching scientific history unfold in real time, and the latest data, especially a brand new, jaw-dropping images from the Hubble Space Telescope, has the entire astronomical community scrambling for answers. Let's set the stage properly. This story began on July 1st, 2025. A telescope down in Chile picked up a faint, incredibly fast-moving speck against the dark background of stars. At first, it looked like just another rock, but as soon as the orbital calculations came back, the red alerts started flashing. This object wasn't circling our sun. It was on a hyperbolic trajectory, moving with such extreme speed that it could only mean one thing. It didn't come from here. It came from the deep, freezing void between the stars. It was designated 3I Atlas, confirming it as our third interstellar visitor after Oumuamua and Borisov. Now, usually, interstellar objects fall into two camps. You have Oumuamua, which was a tumbling, inactive cigar shape, and you have Borisov, which looked exactly like a normal, fuzzy comet. But 3I Atlas, it is refusing to fit in either box. It combines traits of both, while adding new mysteries that defy explanation. Here is the bombshell. Hubble pointed its lens at 3I Atlas again on November 30th, 2025, capturing it as it moved away from the sun, currently about 286 million kilometers from Earth. In this image, we don't see a normal tail. Remember, solar wind pushes gas and dust away from the sun. That is Comets 101. But 3I Atlas is displaying a teardrop-shaped, glowing halo with an anti-tail pointing directly toward the sun. Let that sink in. It's flying away from the sun, but its tail is reaching back towards it. While anti-tails can sometimes be optical illusions caused by the angle of observation, this one is persistent. It maintained this shape before perihelion and after perihelion. It's not a trick of the light. It's a physical structure that seems to track the sun's position perfectly. And the strangeness goes deeper, literally into the math of its movement. NASA's Jet Propulsion Laboratory has been tracking its path with extreme precision. They found that 3I Atlas is accelerating. It has non-gravitational acceleration, meaning something other than gravity is pushing it. It's speeding up away from the sun slightly faster than it should. Now, comets do this when ice melts and jets of gas act like thrusters. But here is the mystery. For 3I Atlas, this mysterious push follows a mathematically perfect curve. It scales inversely with the square of the distance from the sun. This is bizarre. Random jets of melting ice are usually chaotic and messy. They sputter and spin. But this force is smooth, consistent, and mathematically elegant. It mimics gravity's own laws almost perfectly. Why would a chaotic process like melting ice follow such a precise mathematical relationship? It is acting almost like a mirror image of gravity itself. It's suspicious, it's unexplained, and it's physics telling us that something highly unusual is happening right under our noses. Finally, let's address the elephant in the room. If you have been on the internet lately, you have probably seen the videos claiming 3I Atlas is an alien spaceship, a derelict probe, or some kind of solar sail. There is wild speculation out there, some of it fueled by how truly bizarre the scientific data is. When you hear about non-gravitational acceleration and perfect mathematical curves, it is easy to let your imagination run wild. Even serious scientists like Avi Loeb are having to ask uncomfortable questions because standard natural explanations are struggling to fit all the anomalies we are seeing. But here is the beautiful thing. We don't need aliens for this to be exciting. Science works by following the evidence, even when it leads to strange places. If 3I Atlas is natural, it is a new kind of natural object we have never seen before. A dark swarm of non-volatile material that survives perihelion? That alone rewrites the textbooks. It forces us to rethink how planetary systems form and what happens to the debris they eject. And it is not just the professionals who are seeing this. Amateur astronomers are playing a huge role here. A 12-inch telescope in Namibia recently captured wide-field images showing the structure extending for millions of kilometers into space. Think about that. Regular people with backyard equipment are capturing data that rivals NASA. This isn't a secret locked in a government server. It is up there in the sky for anyone to see. The field of view in these images spans 6 million by 9 million kilometers, revealing that this object is massive in scale. It rewards careful observation because there is so much going on at different scales. So where does that leave us? The clock is ticking. We are waiting for the February 2026 data dump from JUICE to tell us the chemistry. We are waiting for the March 2026 Jupiter encounter to test the physics. We are living through a scientific detective story in real time. Researchers are publishing papers, debating interpretations, and sharing data as it comes in. This is a developing story, and it is far from over. Whether 3I Atlas turns out to be a weird rock, a shattered world, a swarm, or something artificial, it has already secured its place in history. It challenges our assumptions and forces us to look up. It reminds us that the universe is vast, complex, and full of surprises that we haven't even begun to imagine. So, mark your calendars for February and March. Pay attention to the news. If the JUICE data shows weird isotopes, or if the Jupiter encounter shows the swarm resisting gravity, you will want to be watching. Stay curious, stay skeptical, and keep watching the stars, because the next few months are going to be absolutely wild. We are privileged to be the generation that gets to watch this mystery unfold. This object has traveled billions of miles to tell us a story, and we are finally learning how to listen. The cosmos is speaking to us, and for the first time, we have the tools to understand the message. Let's zoom out for a moment and talk about the bigger picture. Why should you care so much about one rock flying through space? Because 3I Atlas isn't just a rock, it is a messenger from deep time. Based on its speed and its hyperbolic trajectory, this object is likely older than the Sun itself. It has traveled through the galaxy for potentially billions of years before stumbling into our neighborhood. It travels at roughly 0.2% the speed of light. That sounds incredibly fast to us. It is fast enough to cross the distance from Earth to the Moon in minutes. But for an interstellar voyager, it is a slow cruise. At that speed, it takes about 20,000 years to travel just 1 light year. The nearest star system to us is over 4 light years away. This means 3I Atlas has spent eons drifting through the freezing, absolute darkness of the void, untouched and unchanged, potentially for hundreds of thousands of years or more, only to wake up and become active the moment it hit our sun's heat. Comparing it to our previous visitors gives us chills. First, we had Oumuamua in 2017. It was weird, a tumbling cigar shape with non-gravitational acceleration but no visible tail. Then we had Borisov in 2019, which looked exactly like a normal comet with a standard tail and predictable behavior. 3I Atlas is like a hybrid monster. It has the visible activity of Borisov, but the weird, unexplained acceleration of Oumuamua, plus this impossible anti-tail geometry that neither of them had. It is combining the strangest traits of its predecessors and adding new mysteries of its own. And the fact that we have found 3 of these objects in less than a decade is startling. It implies that the galaxy is teeming with debris, or probes, flying between the stars. It suggests that interstellar space isn't empty. It is a busy highway, and we are only just now building the technology to see the traffic. For every one we see, there must be millions we miss because they are too small or too dark. 3I Atlas is proving that objects from other stars play by different rules than the comets born in our own backyard. Studying it gives us a direct sample of material from a star system light years away. This is our chance to examine an object that formed around a different sun without having to travel there ourselves. It is interstellar travel, But in reverse, the aliens are coming to us in rock form. Consider the composition. If this object came from the thick disk of the Milky Way, it might contain ancient materials that date back to the early formation of the galaxy. It could carry the chemical signature of a dead star or a planetary collision that happened before Earth even existed. Every photon of light bouncing off it carries information about its origins. And unlike Oumuamua, which we caught on its way out when it was already too late, we have been tracking 3I Atlas for months. We have a complete timeline, pre-perihelion, perihelion, and post-perihelion. We are building a three-dimensional picture of how an alien object behaves when exposed to our sun. This is unprecedented. We aren't just taking a snapshot. We are filming a movie of its life cycle. It allows us to test our models of physics in ways we never could before. There is one specific detail about this object that really emphasizes how strange it is, and that is stability. Usually, comets are chaotic, messy things. As they get close to the sun, they heat up, jets explode from the surface, they tumble, and their tails swing around wildly as the solar wind hits them. But 3I Atlas is distinct. Hubble observed it in July, before it got close to the sun, and again in November, after it passed the sun. In both images, that teardrop shape with the sunward anti-tail was there. It hasn't changed its geometry. It is maintaining a consistent, locked configuration relative to the sun. This implies that whatever mechanism is creating this swarm or structure, it is incredibly stable and persistent. It is not a temporary outburst or a trick of the light. It is a permanent feature of the object that has lasted for months. This suggests that if there is a swarm, it is being held in that specific formation by some kind of force or acceleration mechanism that doesn't fluctuate. It creates a picture of something organized, rather than something that is just falling apart. And that stability is about to face the ultimate stress test. In March 2026, 3I Atlas is going to fly past the king of the planets, Jupiter. Jupiter is the bully of the solar system. Its gravity is absolutely massive. We have seen what it does to comets before. Back in 1994, comet Shoemaker-Levy 9 got too close to Jupiter, and the planet's tidal forces ripped it apart into a string of fragments that then slammed into the planet. Jupiter's gravity is strong enough to significantly alter the trajectory of anything that passes nearby. We actually use Jupiter for gravity assists to send our own spacecraft to the outer solar system, stealing a bit of its momentum to fling our probes further out. This encounter is going to be a live-action physics experiment on a galactic scale. If 3I Atlas is really just a loose swarm of debris, Jupiter's gravity gradient, the difference in pull across the width of the swarm, should rip it apart. We should see the swarm scatter, disperse, or distort into a long chain. We might see the anti-tail shape break up entirely into multiple components as the gravity of the giant planet tugs on each individual piece. But what if it doesn't? What if it flies past Jupiter and keeps that perfect teardrop shape? If it maintains its formation against the tidal forces of Jupiter, that would suggest there is a binding force holding it together that we simply don't understand yet. Is it gravity? Electromagnetism? Something else entirely? Scientists are going to be pointing every available telescope at Jupiter in March. Ground-based observatories, radio telescopes, space telescopes, everyone will be watching. It creates a spectacular imaging opportunity because both Jupiter and the interstellar visitor will be visible in the same part of the sky. We might even see thermal emissions or changes in brightness as it interacts with Jupiter's intense radiation belts. It is a make or break moment for the swarm hypothesis, and potentially the moment we learn the truth about this object's internal structure. If the trajectory changes exactly as predicted by gravity, we know it's a passive object. But if there is a discrepancy, if it resists the pull or moves unexpectedly, it will confirm that the mysterious non-gravitational acceleration is a powerful force to be reckoned with. While the Hubble Space Telescope is doing incredible work observing from Earth orbit, we actually got luckier than we had any right to be. by a cosmic coincidence that happens once in a lifetime. We have a spaceship out there right now called JUICE. That stands for the Jupiter Icy Moons Explorer. It was launched by the European Space Agency to study the giant planet Jupiter, but in early November 2025, its path crossed just 66 million kilometers away from 3I Atlas. This was a golden ticket, and the European Space Agency didn't waste it. On November 2nd, JUICE stopped looking at the stars and pointed its cameras and scientific sensors directly at the interstellar intruder. Even though it was using a navigation camera designed to track bright stars for guidance, the image it captured was tantalizing. It clearly resolved the active, glowing coma of the object, that halo of gas and dust, and hints of two distinct tails. One appears to be a plasma tail made of electrically charged gas stretching upward, and the other a fainter dust tail stretching in a different direction. So, we have a close-up eyewitness. But here is the frustrating part that is absolutely killing space fans and scientists alike. We don't have the full data yet. JUICE didn't just take pictures. It collected a mountain of scientific information using 5 different instruments. It used spectroscopy to analyze the chemical composition, particle detectors to physically taste the dust, and plasma wave instruments to listen to the magnetic environment around the object. We basically gave this object a full medical scan. We know the data is there, but we can't see it. Why? Because right now, the JUICE spacecraft is relatively close to the Sun in its orbit, and it has to use its massive main antenna as a heat shield to keep from frying its sensitive electronics. That means it can't point that high-speed antenna at Earth to beam down the files. It is forced to trickle data back through a tiny low-gain antenna, byte by byte, incredibly slowly. We have to wait until February 26, 2026 for the full scientific data dump. Just imagine the tension in the control rooms. The answers to this mystery are sitting on a hard drive millions of miles away, slowly downloading across the void. That data will tell us definitively what 3I Atlas is made of. Is it water ice like our comets? Is it frozen carbon monoxide? Or is it full of organic compounds or complex metals that don't belong in a standard comet? If the spectroscopy shows unusual molecules or weird isotopic ratios, it could prove the object formed in a star system completely different from ours, perhaps one with a different chemical makeup entirely. And just to give you a sense of the sheer speed involved here, 3I Atlas is moving so fast that it will actually beat the JUICE spacecraft to Jupiter. It will arrive there years before our own probe does, reaching Jupiter in March 2026, while JUICE won't get there until July 2031. It is a race between human engineering and an interstellar speedster, and the rock is winning by a landslide. This delay is agonizing, but it also gives us something to look forward to. When that data finally arrives, it's going to be like opening a time capsule from another world. We will finally see the chemical fingerprint of an object that has traveled across the galaxy. Until then, we are left to speculate on what those 5 instruments saw in the darkness. Did they detect a magnetic field? Did they find complex hydrocarbons? Did they hear the whisper of plasma waves interacting with an alien object? The suspense is real, and the clock is ticking down to February. Okay, so we have established that 3I Atlas is behaving in ways that simply shouldn't happen if it were a normal comet. We have a tail pointing the wrong way and a mysterious engine pushing it against the grip of the sun's gravity. How on earth do we explain that? Well, hold on to your seats, because the leading hypothesis right now sounds like something straight out of a hard science fiction novel. Researchers are proposing that 3I Atlas is not a single solid rock like the comets we are used to seeing. Instead, they think we might be looking at a massive, organized swarm of objects traveling in formation. Imagine this for a second. Instead of one big, solid nucleus, picture a cloud of potentially trillions of tiny, separate fragments flying together through the void. This is the swarm hypothesis, and it changes everything about how we view this object. It suggests that what we are tracking isn't a lonely wanderer, but a fleet of debris moving in unison. Here is the physics behind why this explains the mystery. Remember that strange push, the non-gravitational acceleration we talked about earlier? Suppose the main, heavy body of 3I Atlas is getting that push. But what if the trillions of tiny fragments flying around it aren't getting that same push? In the vacuum of space, physics works differently than on Earth. If the main body speeds up and the surrounding swarm doesn't, the swarm will naturally start to lag behind. And in the complex dance of orbital mechanics, as you move away from the sun, lagging behind effectively means you stay slightly closer to the sun than the main body. This would create exactly what the Hubble Space Telescope is seeing right now, a trail of material stretching sunward, not because it's being blown there by solar wind, but because it is physically drifting behind the accelerating main body. It is a debris field being left in the dust, quite literally. The math supporting this is frankly scary in its accuracy. Scientists crunched the numbers to see if this idea actually holds water. They calculated that if this separation started at perihelion, the object's closest approach to the sun, those lagging pieces should be drifting about 54,000 kilometers behind the main body by late November. So what did Hubble see? The telescope measured the anti-tail and found it extended about 60,000 kilometers. The prediction and the reality are almost identical. This isn't just a wild guess or a vague theory. It is a mathematical model that fits the real-world observational data like a glove. And this hypothesis solves another massive problem, the brightness. If 3I Atlas were just one dark rock, it wouldn't be as bright as it is. But if you take a rock and shatter it into a trillion tiny pieces, you create a massive amount of surface area. The combined surface area of a swarm could be 100 times larger than the nucleus itself. This explains why 99% of the light we see in that glowing halo is coming from the extended material, not from the center object. We are essentially looking at a giant glittering cloud rather than a single stone. But here is the catch that keeps astronomers up at night. These objects have to be non-volatile. That is a fancy scientific way of saying they aren't evaporating. If they were made of normal comet ice, they would have melted away or broken apart by now, messing up the formation. So what exactly are they? Are we looking at a cloud of rocky gravel? Are they metallic shards that can withstand the sun's heat without flinching? Or is it something even more exotic? The fact that this structure is holding its formation without vanishing is one of the biggest anomalies we've ever encountered. This implies a durability that suggests these fragments are made of something far tougher than the frozen slush we usually find in our own solar system. It forces us to ask, what kind of natural process creates a trillion durable fragments that travel between stars? The swarm hypothesis is currently our best fit for the data, but it opens up more questions than it answers. Thanks for watching. Please like, comment, and subscribe. It really helps me create new videos. See you in the next video.